I'm Kenton McHenry. I'm from NCSA, the National Center for Supercomputing Applications at the University of Illinois. And what I'm going to talk about today is technology that we're leveraging as part of the Permafrost Discovery Gateway to handle its data management and analysis. So first off, I want to just give a little background. So I lead a team at NCSA of what are called research software engineers. We are software developers essentially, but we are embedded in academia. We work with our colleagues and collaborators, researchers, students in their labs, in their projects to develop research software. And the way this typically works is they come to us with research goals and research code, and we kind of take it to another level in terms of reusability and sustainability, a little bit closer to production. And in that way, it can be leveraged across a variety of efforts for a variety of different things. And that's largely what I want to talk about today, too, in terms of what we'll be leveraging here for the PDG. So why are we here? We are largely here because of data. Data is a huge part of science these days. It's essential for everything. But we're not talking about just any data. We're not talking about movies on Netflix and stuff like that. We're talking about scientific research data. This involves often large amounts of data and level of precision and so forth. But often cases, it's not enough in itself either. You want to do something with that data, so some plus aspect to it. And this involves a number of different things from dealing with metadata, pre-processing, visualizations, sharing, and publication. And these often require aspects of computation and interaction with the user, ideally a user-friendly kind of interaction. And this falls into this kind of growing domain of what's called scientific gateways. These are these portals, usually web-based, where it's usually user-friendly. At least the goal is to be user-friendly, and to really hide away the complexities of these underlying aspects around computation, data storage, data movement, analyses, complex algorithms, and so forth, while also making them available for users who want to have access to those. But for the broader community to kind of hide some of that complexity away. And so the one we're talking about today here is Clowder. And so this is one of the NSF CSSIs, cyber infrastructure for sustained scientific innovation. It kind of fits into the portfolio of NSF investments in regards to this integrative services layer here in the middle, connecting up with a number of different services, but are largely around data management and sharing and the usage of data. So Clowder came from actually a very grassroots kind of origins, spread out across a number of scientific domains, all needing similar kind of capabilities. And so us at NCSA, being this kind of RSD group working on across these different projects, kind of saw this common need. And rather than building a bunch of one-offs, built up this framework that can kind of be customized to meet these different scientific needs that we've been seeing. An interesting aspect of this CSSI is in the sense of, and what makes Clowder a little bit different are actually two things. One is that it's open source and really built on this idea of customizability. And the key aspect there is that you'll see technologies similar to this across different scientific domains, often built with the notion that each domain has very different needs. And what you end up with the result is dozens of these things that at the end of the day look very similar, but are kind of locked away and not as usable for other scientific needs where they could leverage 90% of what was built. And so Clowder kind of tries to address that by building this open source framework that's reusable and could be customized as needed for the specifics of scientific domains. And second is one of its core aspects is the idea of analysis going along with the data. And so as data is ingested into the system, there's this pipeline of tools that automatically fire off to try to process metadata, create visualizations, and so forth. And so that's one of its key features. Over the years, it's been used to stand up a number of different these gateways for different scientific domains. From the first view of it, it kind of looks like this general kind of Dropbox like look and feel. But you can do a lot more once you get into it in terms of visualizing the data and annotating the data and running analyses. And so it's been used for domains such as material science, in this case, dealing with microscopy images and the vast amounts of metadata associated with material science, to things like cultural heritage as part of this European Union effort, where you have these 3D artifacts and you want to annotate them in 3D and assign metadata in that way. To things like phenomics, where in this case for the TerraRef effort, an ARPA-E effort, you have this vast amount of data coming in from across the country from this giant gantry filled with sensors over this field daily. And basically you want to process that data to kind of monitor how the genetically varied seeds grow differently per day. And so we're talking about terabytes of data per day and processing along with that. And then industrial efforts that can also leverage these things. So we have a very active collaboration with Syngenta to kind of do some of that stuff there as well. And so the key aspect of this is the customizability. And so one aspect of that is right off the bat is the metadata. The system was built in such a way so that the metadata, underlying metadata, can be completely changed. There could be tools associated with it also to help users kind of populate that metadata so they don't have to kind of just know what that should be. They could be walked through that. As I mentioned, these tools that fire off automatically, we have a catalog of those things built up over a number of different projects. And so these things can cover things like dealing with microscopy images, finding parts of a cell that have to do with some biological aspect, to looking for old rivers and old manuscripts and overlaying them on current day maps, along with modern day floodplains to kind of see how those things kind of line up. To extracting handwritten text and associating that as metadata with a document, to dealing with educational materials such as presentations, to tracking people in videos and seeing how they associate with each other over time, all kinds of different things. To more complex scientific things like from LiDAR data, identifying the species of trees from that and labeling them and counting them and so forth. And so there's been a body of those that have been built up over the years associated with this framework, and the idea is to make them available so that others can leverage them where need be. And then on the analysis front, we leverage this technology that we built as part of the National Data Service effort sometime back called the NDS Workbench, which allows us to basically spawn off different tools right from the web page and automatically have them associated with the data set you happen to be looking at so that it can be loaded straight into that, and then you can do something with that. And then lastly, the very way it looks. One of the things we often do with the framework is change the way it looks. So these dashboards, make it look completely different. It doesn't have to look like a Dropbox. It could look like a mat with sensors on it to various other things, as well as be accessed on a mobile device. And so we can look at data in that way. And so as part of the Permafrost Discovery Gateway, we're dealing with very much kind of these core aspects. We have large amounts of data in the form of typically satellite data. And what we want to do is basically process it to find different things, such as these ice-wedge polygons, which are artifacts of permafrost melt, to fire scars or lake boundary changes over time, and things like that. So a large amount of processing is required using machine learning to derive these data products, which in turn are fairly large themselves. And that is really what we want to make available to the permafrost community to study that. The idea is to kind of process this data annually, perhaps, generating these derived data sets annually, and providing this environment by which a user could come in and do something with the data. So taking this Clowder core framework, these are the guts of it. You don't have to understand the every aspect of it, but kind of down here is where these custom tools come in, the extractors and converters for file formats. The custom visualizations and so forth, and the aspects of where even the data is stored is customizable, so we can change that, and that's a key aspect with the PDG. So I won't go into the details because Matt Jones will be giving a presentation about the overview of the Permafrost Discovery Gateway in just a little bit. But basically, what we're doing here is using Clowder as kind of the glue to bring the various aspects of the PDG together, from the community tools to actually find these things like ice-wedge polygons or fire scars and so forth, to these custom previews like the Fluid Earth Viewer and integrating them together, the data sets required, and then the final archive at the Arctic Data Center. And so I'll leave it at that, and thank you for attending this presentation.